Hello, everyone. Welcome to another episode of 401 Access Denied. I'm your host, Joseph Carson from Thycotic, and joined with me today is, of course, Mike G. So, Mike, do you want to give yourself a bit of an introduction?
Yep, Mike Rowan, sometimes called G. So if you hear that, that's what that is. CISO and VP of Engineering here at Cybrary. Super excited to talk today. And we're once again joined by Josh Lospinoso from Shift 5. Josh, why don't you give a quick intro?
Sure. Yeah. Josh Lospinoso, founder, CEO of Shift 5 OT cybersecurity company.
Cool. Awesome. And today's going to be an interesting topic. We're going to take a bit of a segue from the normal kind of, looking at different technologies and threats and trends. And we're going to get into one of the things. So one thing that I do often is when I go to different events, we kind of tend to go around all of the booths and we take a look at all of the trends and what's happening and what's new and what's interesting. And there's a game we tend to play, which is buzzword bingo. It's a kind of, you've got your things that's in the list, which is, this looks like it's real. This looks like it's, interesting, needs further research. And then the other thing is really what you're determining is what's really bullshit and FUD. And that's ultimately what we kind of look into. And there's a lot. One thing is the cybersecurity industry is really good at doing is creating a lot of new buzzwords. We like to do, new trends, come up with new ideas, new basically labels for everything. And ultimately, what we're going to do in today's show is really kind of pull some of those apart, is really kind of look into the reality of what really it is and what does it mean? What is the reality check of a lot of these buzzwords that you see in the industry, whether it being walking around in booths, whether it being the messages you get in email or things you attend in webinars and so forth, or the collateral and kind of messaging that you get in a lot of products. So you're going to kind of pull back and look through and really check on some of those things. So, Josh, kind of going to yourself, what's the latest buzzwords you've heard in the industry? What's the terms that has everyone excited, or what's the silver bullet of security? What's going to save us all?
Yeah, I think the big three villains in this discussion, which we'll definitely cover in this episode, is ML, AI, and quantum. And what's so dangerous about these terms is that there's always a kernel of truth to sort of like what these things are and how they're going to have pretty profound ramifications on cybersecurity. And, frankly, like potentially human lives in general beyond cybersecurity. But as ever, it's the way that these things get applied and sort of, universally hyped up around essentially everything. I guess like blockchain was there a couple of years ago and we've sort of like gotten off of that sugar high and we're realizing that like, okay, maybe there are some contexts where decentralized trust could be really important, but it's not going to solve everything, right? So I think this is just a very...
Wait, hold on a second. Blockchain's not going to solve everything?
Absolutely.
Sorry, man. You heard it here first.
It's not going to save humanity, that's for sure.
Yeah.
Right.
I think quantum's an interesting one to start with, just because I think back all the way to when I was first getting started in my career and quantum computers. And I was starting in 96, 97. I remember, SSL started coming out. I don't remember exactly how old, but around that same time frame. And how quantum was going to change everything, how encryption wasn't going to matter once quantum computers were a real thing, and so on and so forth. And I feel like nothing has changed in 30 years. I feel like quantum, we've made about as much, like it's always just out of reach. It's always just there. And I'm curious what your guys' opinions are on that.
Yeah, maybe I don't know, like if the listeners, if they are like read on to what quantum computers, maybe it would be a good thing to just go through a 30.
Oh, it's just something you put in front of anything to imply big, right. Fast, new.
Yeah.
Super good.
Yeah. It just means more better.
More better.
But I could give it a shot, and then maybe we could, go around. I think that'd be maybe a good basis, because it really is. If you don't understand, like, at least the high level of how quantum computers differ from classical computers, it's basically impossible to determine what is like real observations about where cybersecurity is going versus like total misdirection. So basically, like, traditional computers, classic computers, operate with transistors that exist in basically states of 0 and 1, and they're deterministic, right? And everything that we've built modern technology on depends on these sort of states of 0 and 1s, and everything is built up from that. When you get down into the teeny tiny world of nanometers, things get really weird. And like what makes intuitive sense to us about how objects behave in the universe completely breaks down. Like we don't really have good intuition. There's a famous physicist, Richard Feynman, who says anybody who says that they understand quantum mechanics, have an intuition for it, is totally bullshitting, because it doesn't make any sense. Essentially you've got things that can exist in a probability of states. That they're not 0 and 1. They're sort of tending towards one or the other. And so some crazy mathematicians were like, hey, what if we make a computer out of these things that exist sort of in this superposition of 0s and 1s? So instead of calling them bits, which is the 0 and 1 of classical computers, they exist in this superposition state, and then we call these qubits, right? So for right now, maybe we could stop there and sort of maybe see if that explanation makes sense, because insofar as it does.
I think it's going to make sense to the people. At least it makes sense to me, because I've been following it for a while. And I think what was interesting back in the 90s, one of the other comparisons was in the biological world, where you can use bacteria and other sort of biocomputers to do very similar things of trying to test everything at once, sort of just due to probability, you're going to get the answer. I haven't, at least biocomputing hasn't continued the hype that quantum has. But yeah, the multi-state, the idea, I think the key to the whole quantum is that the idea is that you're able to process things sort of in parallel in this, because there's everything's in multiple states simultaneously. You can sort of do things massively parallel or whatever. It's sort of hard to, if you don't know the physics, it's hard to
totally
sort of.
Correct. And it was getting into the qubits. It's really getting down to is the difference between that and binary and bits that we've traditionally known is that where a bit can be either on or off, as Josh was mentioning. In a qubit world, it can be actually up to 4 different states at any one time, and therefore, basically, the computational power of that is significant to what our traditional computers had the capability of doing. But it really gets into is that the taking advantage of them is the difficult part, is creating algorithms that can actually be processed in a quantum kind of computing world. And that's the challenge. And so one of the things I've seen is that the likes of, you've got these hybrid ones. You've got, of course, it's the D wave and E waves coming from, I think it was Google and NASA. And then, of course, you've got IBM's version of the Quantum One. And all of these, what really they're looking for is that they're hybrids at the moment, which is really kind of where they're at. They're not into true, quantum capabilities. But the kind of, when you think about it, is that the idea is they're looking at, you can put in all moving objects in space, all planets, asteroids, comets, and put it into these algorithms. And what a quantum computer could potentially do is tell you when those comets and asteroids could actually collide with the Earth. So ultimately, that's the power that they have the capability of doing. But we're getting that close to capability. Of course, our concern in the security world has always been that you take that same type of computational power and you apply it to prime numbers. And that actually then weakens the security of traditional encryption today. And that's the concern. So there is these hybrids that do exist, and I believe China still has, one of the kind of the computing, the one that has the most qubits capabilities. But I did learn a lot. It's not about how many qubits you have; it's actually the quality of the qubit itself, and that makes a big difference. So ultimately, the concern here is that eventually, if someone does get the capability of taking a quantum computer and targeting against prime numbers and traditional encryption, anything that we've encrypted historically in the past is publicly available or available, to that person, that they could break the encryption. So that's the major concern from a quantum perspective. Are we there yet? I don't know. I just kind of get from what I can kind of publicly available and what I hear. But my understanding is that getting to true quantum is still a long way to go.
Yeah, that's my understanding as well. And I think the one of the things to understand about where quantum computing and regular computing, at least from a traditional computer science perspective, is the notion of NP problem. NP complete, NP problems that are difficult to for a computer to solve, but very, very fast to prove. So if you have the solution, you can verify that is the solution in polynomial time, very, very fast. But actually coming up with the solution takes a long time, and that's what is at the heart of encryption, is this ability. It's really, really hard to break the code, but once you have the answers, it's very, very fast to compute the solution. And so quantum basically is looking at taking this whole class of problems and turning them from very, very hard into very, very easy, like anything else, like sorting a bucket of strings, which is polynomial, being able to do that with non-polynomial problems. And that's, I think, at the heart, and that's what the heart of encryption is. It's these functions that are, hard in one direction, but easy in another. Otherwise, we wouldn't be able to do banking online in any type of real time.
Yeah.
Right.
There was an interesting series recently on the same topic, which was devs. I don't know if you got to watch the series devs, which was interesting. And it got to the point where it was looking at using similar computational power. And if you took all the data that we have around us about how everything happened, that it could actually, it could look into the future and also look into the past as well, if you really take all the objects. But again, I did listen to an interesting audiobook recently on a similar subject, which was the science of science fiction, which is also a really interesting topic as well. It's about all the things we see in the movies and the science fiction side of things, and really looking at the science of that. And really kind of think from quantum side of things is that we do know the aspects of it and we do know the possibilities, but getting to really utilizing it for its value that it can provide is probably, some years away, I believe.
Yeah, for sure. Yeah. I mean, I think it's also really important to specify which kinds of encryption are subject to getting totally broken apart by quantum.
Yeah, that'd be great. Yeah.
Yeah. So, I mean, you guys have basically illuminated it, but just to be really explicit about it, there's sort of two broad classes of encryption, at least as far as this conversation is concerned. So there's, symmetric and asymmetric. So, things like doing a banking transaction online require what we call, asymmetric or public key cryptography, where there's a public key. I'm going to encrypt some data using that key, and the only person who can decrypt it is the holder of the private key that corresponds to that public key, right? So much of what we do in modern society depends on the security of that crypto system. And Joe, as you mentioned, the math that underpins the security of that crypto system right now can be broken by quantum algorithms, right? So, if you're talking about elliptic curve or integer factorization, these are problems that are a quantum computer can solve them very quickly, and things will break. If we get quantum computers, the way that things are set up, people that are using these very, up to now secure algorithms are going to be in deep trouble, right? The world's not falling. The sky's not falling. I'm an optimist about this. There are quantum resistant algorithms that are in active development right now. So there's things that I don't understand these. So but I know that they exist. There's lattice-based cryptography. There's hash-based cryptography and code-based cryptography, and all of these things. Basically, the Shor's algorithm, which is the algorithm that breaks all of the current public key crypto systems, doesn't work against these new ways of doing encryption. So I'm hopeful that we're the quantum computers aren't going to destroy the world. I think there's a lot of active discussion about when do we start migrating to these quantum resistant things, and we'll see. It could be decades before we see practical practical quantum computers, you're almost certainly not going to see one on your cell phone. I think, I mean, you have to to get qubits, you have to have actual absolute zero temperatures, it's just pretty insane.
Walking around with a refrigerator.
Exactly. Yeah. Very, 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 so probably not going to happen. But anyway, I thought that would be helpful. And then, symmetric key algorithms like AES are already quantum resistant. So they don't, you don't really have to worry there. So I thought that would just be sort of another, to our point of people get really hyped up about quantum computers, destroying encryption. It's always more nuanced than that.
Right.
Correct.
I
it's
suspect.
Specific, yeah.
So go on, Joe.
Yeah, it's a specific type of encryption that's exposed. Right. As long as you have one of the, let's say, the factors, you can actually reverse it. Typically, it's basically created from 2 prime numbers and very large prime numbers. And that's the concern, is if you've got a public key, if you've got some references, then you can actually map it back to a private key. But as you mentioned with symmetric, there is no public key, piece of it. It's all about making sure that you exchange the key in a secure manner, and that's not exposed to quantum.
And given ciphertext, a quantum computer can't just magically create plain text out of that.
Correct. And it's, again, you get into one directional hashing mechanisms, especially what things like as passwords are capped in, is also, depending on how well you assault it and how much let's say, mathematical complexity you put into it, then those are also resistant to attacks as well.
Right. I mean, I think it's kind of clear based on human history when we'll see those resistant algorithms really making it into mainstream, which is about 5 years after the first quantum computer breaks something. Right.
Yeah, that's right. But it also highlights, I was going to say, this also highlights a really important feature of crypto systems, which is, in my opinion, one of the reasons that PGP hasn't really taken off among the security community, which is perfect forward secrecy. This is a really important aspect of modern cryptographic systems, and that may be a little bit of a tangent, but maybe helpful to kind of dive into a bit, because it gets to the point that you're getting to. So perfect forward secrecy is this idea that if an attacker is able to compromise the key material for one communication, it won't compromise all the communications between those two parties. Right. So if you're able to recover the session, the key for a session, it doesn't tell you anything about the other sessions. And so Diffie-Hellman is an algorithm that gives you perfect forward secrecy because of this sort of session key concept. And this just underlines why it's so important to have this kind of security built in, so that if you update the security protocols, you have session keys rather than some sort of global encryption key. So PGP, in contrast, doesn't have perfect forward secrecy, and this is one of the major objections in the security community. It's why we don't use it.
It wasn't PGP the original kind of algorithm using. It was based on the randomness of the mouse movement that created the key. I think that was the original. Right. How the key was originally created was how you move the mouse around, and that's how it would actually the mathematical computation was done.
Yeah, I think basically, computers, because as we mentioned, because they're deterministic, it's actually surprisingly difficult to get randomness out of computers.
Right.
Exactly.
And so there's this funny example. I think it's Cloudflare has these lava lamps set up that they actually derive keying material from.
I mean, there's a number. Yeah, there's basically hardware devices. That's the only way you can really get true random, is having hardware devices that are measuring various things,
radiation from space, and all sorts of
temperature,
LEDs,
humidity, and exactly.
Yeah.
That's because moving into that quasi prime side of things, where we're talking about using music as a source of randomness.
Yeah. Certainly, when I play music, it's definitely random.
So getting into, I think quantum, definitely, if we can look at it from a buzzword, it's definitely something that is real. But the true value of it is going to be likely going to be years away. And, if somebody does get access to a quantum computer, they're probably the last thing they're going to be wanting to do is break encryption. They're going to be wanting to use it, I'm hoping, for the benefit of other things that are more valuable to society.
I mean, I don't know. I think it has to do with the state act. My guess is it's a state actor that's going to get it first, and then they're probably going to use it in both positive and negative ways to benefit.
I think that's probably right.
Like all technology. All technology is used in the same. So for the audience, it is something, but will you have it in 5 years, in your pocket? Definitely not. It'll be a very cold device.
Although you can mess with these things. So there are like pseudo quantum computers now we're going to add all kinds of fancy prefixes to things. So you can actually download environments where there's like a virtual machine that pretends it's a quantum computer, and you can use languages. I think it's like Q#, or there's some other, where basically you can program against a quantum computer, and it'll simulate qubits essentially. So if you're interested in these sorts of things, even though you're not going to get the performance of a quantum computer, you can at least get your brain wrapped around how these things work.
And if you are interested in actually learning about it, one thing I remember when I was doing kind of 4 or 5 years ago, getting into, because I was in Estonia, they use a lot of, innovation areas. And there's a lot of, discussions into different technologies. And one thing I was working on again was from back then was blockchain and quantum. And there was
look at that guy, blockchain quantum.
Yeah, blockchain quantum. And there was a guy, there's a guy in Australia. So just look up Australian guy, qubits. And there's a lot of videos of him explaining. So if you're interested in actually, spending some time on YouTube listening to qubits and how it works, there's an Australian professor that really explains it in a very kind of professor-like manner. So as they all do. So next buzzword, I think that Josh had mentioned as well, is around the AI. And I prefer to call it kind of AI, but this gets into the big topic of what does the A really mean and when we talk about it.
And what does the I mean?
I know what the I is. The I is if statements.
So this is the big one. And I can't tell you, when I go to events and I go listen to webinars and different vendors, the big buzzword is around how they're using artificial intelligence to make organizations and people and society safe. And that is this new kind of silver bullet that will actually solve all problems. For me, I'm always looking at the realist side of things. So I'm just interested, Josh, from your view on what's your thoughts around AI itself?
Yeah, I mean, I think the critical question, it was sort of tongue in cheek before, but what is intelligence is I think a really important question. And because to say what artificial intelligence is, you can't really define that without understanding what you really mean by intelligence. And so, where I think it becomes shorthand, right, where the term's actually used outside of a scientific context is to get a machine to do tasks that would be normally required by a human being, right? And that's an imperfect sort of shorthand, but I think that's where what most people mean when they say AI, right? So I think maybe starting there, but intelligence itself is it's a non-trivial concept. What is intelligence? Do plants have intelligence? Do bacteria have intelligence? I would think we would all say that people and monkeys and whales probably have intelligence, but where do you sort of draw the line on that is I think, a pretty important question to answer.
I mean, I think about it in terms of the I can't remember what the exact quote, but suitably technology looks like magic. At some point, suitably complex technology just is magic. They're in. And I think when I think about AI, that's where I start to go is the complexity of the system is approaching to the point where its decision-making is so complex that I can't really explain it. It's because there's so many nuances. It's taking in so many things. I can't explain how I make a decision. Right. You know what I mean? And to me, that's magic that's happening in my brain. AI sort of it's when computers get to that point where you're no longer really able to fully communicate how that decision is. And that's how I where I draw that line is in artificial intelligence.
Yeah. So for me, it's so based on Josh and Mike, your kind of descriptions, it reminds me of something I did 20 years ago. That I had a problem with a server that kept, let's say, running out of memory, and the application was crashing. So I created a little thing that we would probably, based on our terminology, we could call it artificial intelligence. I taped a pen to the top of a remote control car and actually scheduled it in order to actually drive into the button on the computer to reset it periodically. So I didn't have to. Is that replacing me from going and pushing the button myself to actually doing it in an automated way? So for me, that's really kind of what draw the line is that, I think doing things is that there's certain tasks that humans do that just physically cannot be replicated by a computer, by the traditional sense. And for me, what I've always been saying is that, and that's why I struggle with the term artificial intelligence, because everything we do, it's all about automating human tasks. And I don't think automating human tasks is truly, the same as artificial intelligence. And that's there's a misunderstanding is that we're sometimes confusing automating human tasks or artificial intelligence. And when you look at the reality, when I go to a lot of the vendors who talk about AI, and I look under the cover, what they're doing is they're automating somebody looking at a log file. They're automating somebody going and analyzing mass amount of data and then trying to come to conclusion. For me, that's just automation. For me, it's automated intelligence, not so much artificial. It's just taking tasks that a human would do that computers can replicate. It might, to your point, be more complicated and look like magic because some of those algorithms do get very, very complex. And so I can remember I actually participated in a summit last year. It's called the Talent Digital Summit. And last year's event was on government's policies around artificial intelligence. And we get into a big discussion around, what did it truly mean? And ultimately we get into, and I liked IBM's term of the A was they call it augmented. When you get into the, let's say the doctorate side of things or the educational, and the professors, they call it artifact intelligence. It's all about artifact collection and understanding about the outcomes. And for me, I tend to call it automation to truly kind of differentiate between what true. The one thing I have seen that gets closer to it is when they're looking at, let's say, automatically translating text into other languages. When you're talking natural language processing, when you're looking at being able to listen to me speak and, not knowing what's coming and then be able to properly translate that correctly into another language. And my definition is that when I really get to see true artificial intelligence is when a program that's only been trained to, let's say, do natural language processing on English and actually can then learn German and then automatically translate German without human intervention. That's kind of what I think about, something that is truly getting closer is what they can truly learn themselves.
Yeah, I mean, I think the learning aspect or the self-modification aspect is also an important part. But, going back to the sort of on the AI side, I think about like one of the problems Josh and I at Red Owl were facing was like, how do you identify someone who might be leaving an organization? And right, so because that's from a security perspective, people who are leaving it, that they're somebody you want to watch.
They're going to take a lot of the data with them.
Right. They're going to, right. They're going to, whatever. Or they're disgruntled and they're going to delete everything, whatever it is. So how do you identify someone who's unhappy and potentially going to leave? And me as a manager, I can sort of get a feel for people who are sort of disengaging and how to, but how do you get a computer to look at whatever behavior they can actually observe, whatever behavior computers can observe about the people within the system and get it to identify someone it thinks might be ready to leave. And I think, what we worked on and what was interesting was I remember sitting down with the mathematicians and we went through all these things, and like we needed to be able to check that our math was right. And how do you even do that? And that's where I started feeling like, okay, now we're getting into the real realm of artificial intelligence, because like we have these models, how do we actually know that they're right? The only way to know they're right is to actually use them on old data sets where we know what the answers were. And I remember saying with the mathematicians, and I wrote my version of the algorithm, and then they would actually have to hand compute things in order for us to make sure that my math was right and their math was right. And 50% of the time I was wrong. 50% of the time they made a mistake somewhere in their Excel spreadsheet. It was a nightmare.
And 25% of the time you were both wrong, but thought you were right.
Exactly. Right. All right. Who knows how many times we both came up with the same answer, but it was the wrong answer. Right. That's a great point. I have no idea. Probably 50% of the time. But yeah, but to me, that's where we were starting to get into artificial intelligence, where that model was so complex and there were so many things going on that it was something that I as a human do, and I do it intuitively, and I couldn't quite explain exactly how I do it to a computer. It's not just a bunch of if statements. It's a buildup of all of these different things and then putting it into a model. And I think that's where we start getting closer and closer to real artificial intelligence and machine learning, and actually looking and, having the computer observe things, training itself, making changes to its own algorithms and so on and so forth. And then you get to the point where the machine is transmuted itself so many times that the original programmer has no idea what's going on in there. And I think that's basically YouTube and Facebook, like in terms of their recommendation engines. Nobody really knows why this video is being recommended to me. And I think that when it comes to cybersecurity and looking at logs, I think those concepts, those are buzzwords that are used in the cybersecurity space to do what you're talking about, Joe, which is like, we've automated the looking at these logs. But the fact of the matter is, I could actually explain if by if what that computer is doing, looking at those logs and flagging things. And it really is just
the algorithm is not self-learning. The code itself is still the original algorithm code that was actually done by the developer.
Exactly. And the way I think what we're talking about is like the idea of cognition, right? It's it's like having this base of knowledge and then experiencing and sensing things and then interpreting that into new knowledge, right? That becomes part of, and so like, I think of like kids, right? And like, this is if you've been a parent and you watch like sort of a child grow, it's like it's the best worst thing that'll ever happen to you, right? But like watching a 3-year-old compile new information, try out sentences, like see what happens in response to the sensory inputs, and then like generate knowledge. It's like the most amazing thing to watch, right? And so, having programmed a lot of computers in my life and, doing my best at parenting children, which is, basically impossible. There's a fundamentally different feel to those things because one carries out your instructions faithfully and literally, no matter what the result is. And the other is sort of going through this very messy process of cognition. And to me, they are fundamentally different. They feel fundamentally different. But to your point, G, when we start talking about these systems that are sort of very flexible in the way that their instructions work and they're compiling information and inputs and presenting new outputs to the world and then like kind of iterating on that definitely to my mind gets a lot closer to cognition.
Right.
Right.
And what's interesting, I think, a couple of years ago, we went to an event here. So the University of Maryland at College Park, we are on their property essentially, and we use the same underlying ISP that they have, right? And this ISP they have to transfer huge amounts of data because they're connecting research environments. When I say huge amounts of data, like this is the first time I've ever heard someone talk about like large data sets, and then they started talking about the size of these data sets and how far they have to transfer them, and how it's like, wow, that's actually really a large data set, like petabytes and petabytes. And one of the things that was interesting that they talked about, he sort of like was calling for, was because the talk was mostly to scientists and researchers and how they're studying the sun and studying the planets and all these different things and all these algorithms that they're using to make, for example, like planes that should not be able to fly, that are in no way aerodynamic, but you put enough sensors on there and the computer can fly this thing despite the fact that it has no business flying. And he was basically saying like, hey, wouldn't it be great if you all took that stuff that you're doing and applied it to the sort of the network data that I'm generating? So these giant transfers, the data generates data, essentially. It's like these giant network transfers are doing all of these things. How would I even detect that there was an intrusion with all this network stuff that's going on? How would I even know what's going on within the network? And if you were to take that scientific research that's being applied to astrophysics and such, and apply it to this, wouldn't that be awesome? And I think that's where there would actually be true like AI and security. But unfortunately, most of the companies that you talk to that talk about AI and security aren't doing that. They're doing a lot of if statements. Right. And so I think I would love to get to that point. I thought that was a great talk, and it was a very inspirational, reminded me of a previous conversation with Josh around, hey, there's all these different areas where we could be putting really smart people to work that are in these hard sciences to solve problems. And here's a problem that's actually really ripe to be solved, but there's not as much interest in it for whatever reason.
Yeah, and Josh, we discussed previously about the one that DARPA was running in the Air Force and doing the
dogfights
against against the AI pilots. And we had discussed, and I remember I saw my cousin was posting about it as well, and they're having a big discussion, and it was all about artificial intelligence 1 and pilot 0 in regards to the competitive side of things. And I've even seen the same, and it's one of the discussions we even look at with Kasparov in chess about playing basically against the so-called artificial intelligence systems. And because it's such, when you look at those, there's such set rules. There's a set of rules that they have. And that's the point where, when I look at it, it's not the pilot versus the other plane, and it's not the chess master versus the computer player. What ultimately is it's the pilot against an algorithm.
Yep.
And if you understand how the algorithm works, then you find the weaknesses, you find the flaws, just like we do in software development. When you look for your penetration tester, you're looking for flaws and vulnerabilities in code so you can take advantage and exploit it. And it's the same with these systems, is that you're looking for vulnerabilities and flaws. So Kasparov's playing against the machine. Really, what he should have been playing against the algorithm, finding out its weaknesses and understanding. And the same with the pilots, is understanding about what there's weaknesses in the algorithm, not looking at from equal to equal, because it's not equal. And ultimately, when I get down to it, I looked at it and I made the comment and said that it wasn't pilots 0, artificial intelligence 1. It was pilot 0, dev 1. It was the developers who created the algorithm, ultimately 1. And that's, I think, for me, is a big difference as well, that we had to get into reality.
And I think there is a difference, though, between, say, chess and flying planes or other things, because chess is all the information is known. Computers should be really good at that type of problem, right? Like, I shouldn't be able to ever beat a computer at chess because all of the information is known. I mean, it's 100% known. Flying a plane, playing other games where there's hidden information. Once we start seeing computers really beating people there consistently, that's where you're starting to get into it. But I think, Josh, can you we started talking about it a little bit. So we talked about AI and we started talking about, self-learning and stuff. Like, maybe it'd be helpful to sort of talk about AI, machine learning.
For sure.
Is there a difference? Why are these two different? What are they? And maybe that would be a good place to go.
Yeah. So, I'll give you my take on it. And I think there's a lot of discussion around these things. So, full disclosure, I did advanced degree in statistics. And so I have a very strong opinion about how all of these things sort of hang together. So take this for what it's worth. But ultimately, as we were talking about artificial intelligence, to my mind, means cognition. It's basically trying to create cognition in a machine. Right. Machine learning is more of a broader class of techniques for solving problems. And so this is where you're talking about things where you either have an inference problem, like you're trying to classify something into one group or another, or
hot dog or not hot dog.
Hot dog, not hot dog.
Hot dog or not hot dog.
Hot dog, not hot dog. Exactly. You're trying to predict a value in the future given previous history of things, or you're trying to sort of separate data without really knowing sort of the truth, but you have some glob of data and you want to pull it out in interesting ways, right? And then a very closely related field, but certainly distinct, is statistics, which is basically you have a hypothesis, a scientific hypothesis about something. You collect data, and then you build a model that is constructed in such a way that when you put the data into it, the model gives you some results, and that result tells you about your hypothesis. It tells you either, hey, this data supports your hypothesis, or there's just not enough evidence to say one way or the other, right? So that's sort of how I think about how all of these things hang together. I don't even know if that's really useful for practical purposes, but when we use these terms, that's how I think about things. Statistics is very scientifically based around like answering scientific questions. Machine learning is a collection of techniques for predicting, classifying, separating, and doing practical things with data. And AI is about cognition. So
right,
absolutely.
But I do think that machine learning is to my definition of AI. Machine learning is actually closer to artificial intelligence in the sense that it's looking at previous things and using that information to sort of modify and
sure.
You know what I mean? And I think artificial intelligence is just a term that's been around for a long, long time.
Right.
I think there is a difference. Though,
yes.
Is with machine learning, it's really about we use the same for predicting the weather, and that's one of the kind of areas you have. You've got your constants and you've got your variables, and it's about playing around with those different mechanisms to see how far off you are based on the data that you have. So it's really about coming up with enough data to get your probability close enough and accurate enough.
Right.
And based on major different variables, then you can determine if one changes, therefore the result will change. And that's really kind of get into. So it really, I absolutely, Mike, what you're talking about is I think machine learning, AI can't have AI without machine learning. It's
right.
a big part of it. It's a component. It's an input. It's a factor. But when you get into AI, I think the difference is that for me, it's all about self-healing, self-creating. It's about when a developer wrote it, that it will actually continue recreating itself as it goes forward. And when if a developer comes and looks at that code again, it's not the same code it was when they wrote it at the beginning.
Right.
It's self-evolving, self-improving. But one of the biggest challenges, and it's I think an issue that is getting the ethics, ethical coding and non-biased coding. This is really where you get into the challenge: is that how do you take it out of the decisions and so forth?
Oh yeah, no, I mean I mean the problem is right. There's still a human that programmed it. There's going to be biases. I mean, you look at any of these sort of AI systems. They have bias baked in because somebody had to come up with the initial set of rules.
Yeah. I mean, there's this great book called Weapons of Math Destruction that talks about this exact issue. And so you have my reading list. Yeah, it's pretty good. I mean, there's definitely like sort of an agenda behind it, but I think it's one that's argued reasonably. So like I have just a couple comments about this sort of bias things. It's really interesting. One is, you can collect data that just has bias in it. So depending on how you sample your data, you're going to end up with some sort of bias potentially built into that, unless it's like a lab environment and you can do sort of clear A/B testing. You're also going to have bias based on how the model works, right? So there's this like famous statistician called George Box who said all models are wrong, some are useful. Right.
I think his quote is more famous than he is. But
no, for sure it is. I like to, So like to this question of statistics versus ML, I think it's really illuminating to how we build biases into models, right? So. In the machine learning world, when we're trying to draw an inference about something, for example, we're predicting whether recidivism in inmate populations is a really good example to talk about, right? And so if you take historical data and you plug it in blindly into like a classifier, some sort of deep learning model, right? Which, funny enough, this all ties together, but like is a stylized version of how we thought the brain worked like a few decades ago, right? You train these neurons and they'll come up ultimately with a classifier that says, yes, this person will commit another crime, or no, like they will not, for making paroling decisions. It turns out these systems are super racist, right? Like super, super racist. And whereas if it's harder, but if you were to use like a statistical model where you know how the model is constructed, you know which data you're putting into the inputs and how those parameters are coming out, you get a bit more insight into how each of the factors of a person's attributes, whether that's their history while they were in prison, it's their age, it's their demographic information. You can get a better sense for how these things are affecting the decision to parole or not. And
I think it's important to explain why that system is racist. And it's racist because what you've done is you've codified all of the racism that was built, like everything that was in the original model, like all that data was coming from what was a systemically racist system in the first place. So you've just codified it. Congratulations.
Right. Exactly. And the problem here is like essentially that the machine learning models are incredibly opaque, right? Like they're built in these, they're fascinating and they do incredible stuff. They can drive cars, these like convolutional neural networks and stuff. It's amazing. Like, don't get me wrong, it's amazing, but there's a fundamental problem of like introspectability. Like you can't look into these models and say, oh, this is why this algorithm is making this decision. It's, it's static. So it's not like these things are necessarily evolving over time, but they're like just very opaque. Whereas statistical models, at least the good ones, like you can go in and you say, oh, these parameters are affecting the outcome in this way, right?
And again, I think that's
supposed to be that way.
That's also another reason why I think of machine learning being actually a little bit more like going back to your talking about kids and watching them and so on and so forth, right? I don't think anybody would argue that a kid that's raised by a racist family is probably going to be racist. And so it's a very similar, if this is the data you're putting in, this is the result you're going to get out of it. Which makes it a little more, obviously these two things are connected. Statistics is definitely much better, and I worked on an NLP company, and I remember talking to them, and there were a number of linguists that were very pro the statistical approach and very anti-statistical approach. And it was always fascinating to watch those arguments unfold.
I think we're getting to the point, your result is only as good as the data that you put into it.
Totally. And the machine you put it into.
The machine you put it into as well.
And the developer that makes that machine, I think.
And everything.
So it's all crap is what we're saying. I think.
It's all crap.
At the end of the day, it has human nature built into it.
Totally.
That's the kind of the ultimate impact is that, if we get, I think probably the only true thing is that eventually if you get to a point where it's completely decentralized and the developers who are creating it, and this reminds me of even some of the work I did in the past. When I was working on something, I didn't have the bigger picture. I didn't know what I was working on. I had one piece of the puzzle. I didn't know who I was working with. I just knew that this is what I had needed to create. And then that puzzle goes into something else and then is used for whatever. But if you get into that model where the person doesn't know what they're actually participating in, then you get closer to, and you get many people working that way, that they don't know each other, then that gets a bit more closer to desanitizing it.
And I think
Joe,
multiple people working on the same problem, but yeah, sorry.
Are you trying to say that decentralized AI ML development on the blockchain is the way we're going to solve all these problems? Because if that's what you're saying, sign me up. I think
I think we need to make sure that there's quantum computers involved.
Of course. That's how you do proof of value is on the quantum computers.
With the dice of quasi-prime and music.
Exactly. Yes. You have to play classical music to the quantum computers.
Yeah. Absolutely.
So I think this horse is sufficiently beaten.
Yeah.
We've solved all the problems, guys.
That's also, by the way, I would like to point out another difference between artificial intelligence and raising kids is you can beat a computer.
Oh my God. I think we'll cut the podcast off before that.
It's bringing it to a whole new level. Well, soon you won't be even able to beat the computer if it gets classified as a citizen.
Right. I mean, it does bring up an interesting thing around artificial intelligence and at what point do they have rights and stuff like that. But I think we can hold off on that conversation.
Yes, actually, just to kind of, there is an interesting thing in Estonia. Actually, there is an algorithm in Estonia which is called Kratz, which is interesting. I don't know why they called it Kratz. It's because Kratz is like an evil goblin who comes along and steals your things. But that's what they called it. They called it Kratz. And this is their, let's say, government artificial intelligence official. So if you've got a question, this bot has the ability to go off and find out all the previous types of questions similar and respond to it. So it's almost like a government service official that is there to answer questions of citizens. And it really got into officially designated as it was recently as an e-resident citizen type of thing. Wow. So, and you also even look at the one in Saudi Arabia, which got classified as a citizen as well. The robot, whatever it was, I can't remember the name of the Susie or whatever it was. But yeah, this gets the point is when these devices start getting equal laws to ourselves and equal standings, that's a whole new direction where it can go.
Yeah, it reminds me of Microsoft released this like Twitter bot in like 2016. It was called, remember it was called Tay, and within 16 hours it was like spouting like conspiracy theories and like what was going on, these racist tirades, and I had to shut it off. It didn't even last a day. So I think what we're saying is people are awful, and
I think we just need to act responsibly. That's we have responsibilities, and it's important to stay with stick with the ethics side of things. That's what's critical.
Right.
Sure.
So I think to sum it up is that eventually at some point in time, beat your computer today while you can, because at some point in the future you may not be able to do that. But I think if we go through all of the kind of the buzzwords bingos that we tend to play in the cybersecurity world, is that some of them are reality. Unfortunately, a lot of them are labels more than what they really actually do. Some are a bit further away than others. If we're talking about quantum computing, it is a path, it is a direction, it is reality, but it's years out before we even get the benefit of it. If we get into looking at artificial intelligence, I think it's probably more accelerated in other industries than in the cybersecurity industry. Mm-hmm. I think if you pull back the covers in cybersecurity buzzwords, that for most companies, it really is about automation. Maybe they do have a large value for machine learning participating and contributing to that. So I think machine learning is a massive contribution and value. Because it really comes down to, Josh, as you say, it's as good as the data you put in and the model that you've actually created to what you're really going to get in the results. Because ultimately, people who created the code, it is biased by nature. Yep. So I think ultimately, there is positives. Hopefully this was valuable for the audience and interesting. And I think the final kind of from Mike is that blockchain isn't going to solve all your problems.
I'll say this.
Solve all your cybersecurity problems either.
Right. I'll say this. I mean, I know when I talk to cybersecurity vendors, the ones that impress me the most are the ones that say right off the bat, this isn't AI, this isn't machine learning, this is just statistical analysis, right? We're analyzing the data, we're automating things so that you don't have to. And they're very clear about that. And to me, when somebody says that, and I think very specifically, I don't mind naming their name, Signal Sciences, our first call, that's the way that call was. It was amazing. He was like, no, we're not going to pull your chain or your blockchain for that matter, and say like we're doing all these things. We're doing it's pure statistics, it's pure analysis. Yeah. It's not machine, it's not these things. It's not these crazy things that like are buzzwords.
What you're saying
I think that's an important thing when you're looking at vendors, and I think that's an important thing to take away.
You're ultimately saying is they hired good developers. That's ultimately truly what you're saying.
And smart marketing people that aren't trying to trying to
change the message. So, add the value is that what really companies should be selling is their developers who are really the ones that's really behind creating it, and rather than trying to create some kind of fictionist message at the end of it. So, Josh, any
final thoughts from you?
Yeah, no, this has been awesome, guys. Thanks for having me on. I think I've been thinking a lot about like embedded medical devices recently and cybersecurity of those things. So a couple of weeks ago, Neuralink, which is one of Elon Musk's companies that's like doing the brain machine interfaces, had some really interesting engineering achievements in making like implants on your like cranium possible. I think that, actual just, we talked about artificial intelligence and cybersecurity. We could probably have an episode about intelligence and cybersecurity and like how these devices are going to be implanted all over our bodies eventually, and how the hell we secure those things would be, I think, a pretty interesting.
Yeah, I think absolutely. It's the combination of both cognitive science and neuroscience together that's really where it's coming into.
Right.
Is when you start not making computers better, but you start making people better with computers embedded.
Right. The future is going to be weird.
Right. But people are the worst. We're never going to make them better. Anyway.
We'll probably make them worse. I mean, if we're being totally honest. So.
Absolutely. And again, Josh, many thanks for having you on. It's been a great discussion as always.
Thanks for
and for the
having
audience. Me. Yeah, for the audience out there, I really kind of want, if you've got buzzwords or things that you want us to talk about in the future, feel free to throw them on either through social, send us a message, post it up. If there's buzzwords that you see that you would like us to discuss, we're more than happy to bring into the conversation. So at the end of the day, stay safe out there, make your choices wisely when you're going to look for solutions, and try to actually pull back what the reality is. And don't just go off the marketing buzzwords. So again, many thanks, Josh. Mike, as always, great having a chat. And for the audience, stay tuned every 2 weeks. Catch up with us on the 401 Access Denied. Stay safe, look forward to it, and take care. Thank you.
See ya.